have two substances mixed at different temperatures, and we need to calculate what is going to be the final temperature for both of them. The first thing we need to remember is that the final temperature is going to be the same for both of them because they are going to be reaching what we call thermal equilibrium, which means the same temperature for both of them. There is not going to be any more energy transfer. For this example, we have 30 grams of alcohol at 20 Celsius. We are combining them with water, 40 grams at 90 degrees Celsius, and we want to find out what is the final temperature. We know the specific heat for the water, and we know the specific heat for the alcohol. So we begin, like always, writing down our data. I have put the values for the data that correspond to the water in blue to make this a little bit less confusing. So we know that we are not adding any energy to the system, so whatever energy is transferred is going to be going only from one into the other. The water is the substance that is hotter at 90 degrees, so whatever energy the water is losing as it's cooling down is going to go into heating the alcohol. So the alcohol is going to be changing the temperature from 20 to some temperature that we do not know. So when we put in the data, we are going to leave T2 as our unknown, both in the case of the alcohol as well as for the water. We are going to distribute this algebraically, where we multiply 30 times 2.57 times T2, and then we're going to also multiply 30 times 2.57 times minus 20. Let's remember that these black numbers correspond to the numbers for the alcohol, and the values for the water are going to be in blue. Once we do our operations, we are going to have two terms that contain our variable that we want to find, and two terms that do not have any unknown or any other variable, and we know that everything is going to be equal to 0. This becomes a linear equation with one unknown. We are going to be solving for T2, where we are going to be the two terms that have T2 together and the other ones together as well. Solving for T2, we obtain that the final temperature for both materials once they have been mixed is going to be a value for 68 degrees Celsius, which makes sense since we had alcohol at 20 and water at 90. So we know the final temperature has to be in between, not necessarily in the middle, but it definitely cannot be either lower than 20 or greater than 90. Unless there was a chemical reaction, our substance mixture is going to be in between those numbers.